One of the most prevalent challenges in robotics research is the poor reusability of software components for different robot hardware. Often new algorithms are evaluated on locally available hardware. In order to assess the performance of new algorithms, the comparison on a standard hardware platform is desirable. Let's make a concrete example. The CV expert Alice has developed a new algorithm on her locally available U-bot. She now wants to evaluate it on a different robot. The BRICS concepts and model-driven toolchain help to increase portability and reusability. But how do you get started with BRICS? It's actually quite simple. The only things required are Broker, the BRICS Open Code Repository, and BRIDE, the BRICS Integrated Development Environment. As a first step, an existing capability component model can be loaded into BRIDE from the repository. If required, the abstract model can be adapted to the needs of the new algorithm. For example, a new interface for a different parameter set. With the Model-to-Code feature in BRIDE, code can be generated from the abstract model. The code generation saves time and reduces potential error sources. Also, many different programming languages are supported by BRIDE. An even more important aspect is the implicit separation of middleware dependent, created by the code generator, and middleware independent code. After adding the actual new algorithm to the CV component, the compilation is triggered. The new component now has to be integrated into the component architecture of the target platform. In our case, the U-bot architecture is already available in Broker and can be loaded into the system deployment view of BRIDE. The new CV component can very easily be added and connected to the respective U-bot components, for example the image input port to the camera node. The system deployment view of BRIDE furthermore allows the configuration of the particular components. A single press of a button delivers a distinct deployment file that allows running the application on the target platform. The new component and the deployment file are tested on the target platform. As soon as the component has been evaluated successfully on the local robot, Alice wants to make her new algorithm available to the community. In particular, she wants her colleague Bob in San Francisco to test it on a different robot, Carabot 3. She therefore uploads the component to Broker. Bob can check the quality of the component in Broker through an incorporated continuous integration server. Bob also uses BRIDE and has already loaded the Carabot component architecture. All he has to do now is replace his CV component with Alice's component. After successful deployment via BRIDE, he can execute the application to evaluate the new CV algorithm on Carabot. Alice also has the possibility to execute the application herself. Bob has connected Carabot to a web portal that allows for remote access. Thus, both Bob and Alice can watch the performance of the robot with the new CV algorithm.